Дорогие участники конференции, мы двигаемся дальше. Далее нас ждет запись доклада иностранного спикера. Это доктор Ezzat, как и ранее я анонсировал. Далее мы подключим, у нас будет прямая сессия для вопросов и ответов к нему. Будет с ним прямое включение. Доктор Ezzat у нас является доцентом кафедры геотехнической инженерии университета принца Султан из Саудовской Аравии.
Good afternoon, everyone. This is Mohammed Ezzat. I'm Associate Professor of Geotechnical Engineering at Prince Sultan University in Riyadh, Saudi Arabia. I'm also the Secretary of American Society of Civil Engineers, ASCE, for the Saudi Arabia section. Besides, I'm serving as a Senior Geotechnical Engineer at Econstruct, a consultation firm in Dubai, UAE. It's my great pleasure to be with you today in Midas International Geo Conference, and I will be very happy to share with you some insight and very interesting case study for one of the unique challenges we faced in one of the recent projects we worked on in Saudi Arabia. Let me share my screen and start our today presentation. The topic I will discuss today is mainly the performance of a massive underground tank rested on uncontrolled rock fill. It's a unique problematic soil. I will explain in the coming few minutes our effort in mitigating or controlling the settlement of this massive underground tank rested on such challenging soil. First, let me give you just an introduction and a brief about Prince Sultan University. We are a private university located in Riyadh in the northern part. Prince Sultan University has 6 colleges, including for sure College of Engineering, which I'm honored to work at which, beside the Business College and Architectural and Design College, Humanities and Computer Science and Faculty of Law. Prince Sultan University has several remarkable achievements and ranked in different prestigious ranking systems, beside obtaining several international and national accreditation for our programs. Our campus has around 7,000 students, and for the engineering college, we have several engineering programs, including the one I'm teaching at which is a civil and environmental engineering program. Besides this, I will be very happy to introduce Econstruct to you, which is one of the organization firm located mainly the headquarters in Dubai in UAE, and also our team is around more than 200 employees located in several branches in different countries in UAE, Kuwait, Egypt, in Cairo and Alexandria, Oman, and in US and several other locations. Our main specialities is structural engineering, precast engineering, bridging engineering, post-tension, and for sure geotechnical engineering, the department I'm working on. We are fostering the multidisciplinary approach. We have a very good reputation among the Middle East. We worked in several mega projects. We also pay a lot of effort, direct a lot of our effort in the computational engineering, which is including for sure our computational models using different Midas software like Midas GTS and several other softwares. I will just pick the few samples of our project and award we obtained for several projects. The first one is Guinness World Record for the Office of the Future, which is the world first 3D printing commercial building. It was a pioneering approach for using 3D printing at that time. In addition, the Engineering New Record ENR Award, which obtained for 1,000 museum for the revisionary method of construction. This just 2 examples for the award we obtained in our project. Also, this is one of the samples of the project we worked on, which is Expo 2020. I guess most of you may be familiar with this remarkable project, and maybe you attend the event a few years ago. Our scope in this project included the structural engineering, geotechnical engineering, and several other aspects. Econostruct in general focus or promoting the value engineering concept in many of our projects. We are collaborating with different contracting and consultation firm in optimizing the cost and time of each project through the different value engineering approach and through innovative design techniques. One of the most innovative branches in Econostruct, which is Base AI. It's like a sister company working through in Econostruct as well, but it's mainly involved in developing and new softwares and AI and machine learning tools to promote the engineering application. Maybe today I will just give a quick exercise related to such area, but maybe for Geotechnical Society, since we are talking today about the geotechnical engineering, one of the very favorite application in Base AI is an application using genetic algorithm in optimizing the pile foundation design. Such application could help you in optimizing number of piles, orientation of the piles, lengths. For sure, all of us spend a lot of time in doing thousands or hundreds of trials there to optimize such foundation system. So I encourage all of you to visit the Base AI website and know more about our application. Okay, now let's move to our today topics. As I explained, the title of my presentation will be Performance of a Massive Underground Tank Rested on Uncontrolled Rockfill. The presentation will cover the following items: nature of uncontrolled rockfills, a case study for a massive tank, proposed foundation system for this case, and value engineering, what we did to optimize the foundation system of this project, and the ground improvement technique we utilized in this project. At the end, I will show a small exercise for including genetic algorithm in the engineering methodologies. Okay, first, let me give you an introduction or just a definition about the uncontrolled rockfill. What is the nature of uncontrolled rockfill? Uncontrolled rockfill refers to the placement of rock material without following strict engineering guidelines, such as proper compaction or grading and quality control measures. For sure, this type of fill often contains large voids and may vary significantly in size and composition, which is for sure will affect the stability of such rock. As you can see in this picture, there is a large diversity in the sizes of the particles. Uncontrolled rockfill has a high potential for sure for long creep deformation because of the restructuring under the different wet shrink cycles or even after under the traditional loading. Uncontrolled fill can pose a challenge for construction projects, leading to differential settlement, increased impermeability, and reduced structural integrity over the time. And for sure, careful attention shall be paid if the rockfill structure include honeycomb-like zones, like you can see here in this picture, that are very loose and may experience local collapse. The extreme inconsistency in lateral and vertical direction, the main characteristics that can indicate the uncontrolled composition, and this can be observed through trial bits. So like the excavation you can see here, many voids can be observed, large diversity in the particle size. So if we are planning to construct a massive underground tank above such a soil, this could be a challenging one. And here I have to clarify this point because this could benefit many of geotechnical engineers. If you conduct SPT test for example, at such a soil, you may find relatively high values. In addition, if you conduct, for example, plate loading test, the engineer could obtain very high results. However, unfortunately, some engineer may incorrectly classify this soil as a dense or very dense soil, which could be misleading. Because the high SPT primarily influenced by the presence of large and irregular rock particles, as you saw in the previous slide, the shape of the soil and the image of the soil. This rock fragment, rather than uniform soil behavior, it's a huge blocks within this soil. Such misinterpretation may lead to inaccurate assessment of the material settlement potential and for sure for the stability of the foundation system. If you CV analysis for such tests, for sure, the very large particles like the one shown in the previous photo will be excluded. As you know, most of the standard recommend that particle with size higher than 63 millimeter could be excluded from the sample. So you may not experience such large boulders within the CV analysis test, and accordingly, the classification of this system of this soil could be could lead to misleading representation. So in such cases, alternative adjustment methods could be utilized, like trial bit and open cut excavation, to realize the actual sizes of the boulders and cubes that may be existed within such soil. The tank we were planning to construct above such uncontrolled rock fill is a massive tank. Its width were around 37 meters, and the length was around 21 meters, with height varies with the level, but in average it was around 6.4 meters. The water capacity of this tank was around 5,000 cubic meter of water. The expected ultimate stresses was around 385 kPa, which is for sure heavy and massive tank. This summarized cross-section explaining the condition. We have the massive water tank and will be and 8 meter of planet soil will be filled above this tank, and this tank is rested on the uncontrolled rock fill with thickness of 13.5 meters, and under this uncontrolled rock fill there was a limestone layer. For sure, like any foundation system we are designing in our daily basis, the foundation system should or must prevent the foundation design must prevent the failure by maintaining sufficient factor of safety. Additionally, we have to ensure that both total and differential settlement within the accepted range. The design requirement for this massive water tank was following for sure the country standard. So according to the Saudi building code, the allowable settlement of any foundation raft should not exceed 60 meters. However, the structural design of the tank limits this settlement to only 30 millimeters to accommodate the structural to maintain the structural integrity of the tank. So we have a strict requirement, which is the total settlement should not exceed 30 millimeters. Also, the working bearing pressure should not exceed 300 kPa. So we have this 30 millimeter settlement, and we have this massive water tank rested in uncontrolled soil. So this is a challenge we are discussing today. At traditional practices, first we start to simulate the actual situation. What if we place this tank on this uncontrolled rock fill with expected with the engineering properties we obtained through different field and lab tests. And when we start to simulate this in a 3D model using MIDA GTS NX, the settlement we found was 76 millimeter, which is almost more than the double of the design requirement. As I mentioned, the design requirement for this case was only 30 millimeter. So the traditional raft foundation may be not suitable solution for such massive tank. The analysis conducted that the disciplinary assessment was stress analysis, traditional stress analysis, using full 3D model, as you can see here in this image. And after this, we started to take the second traditional step, which is what if we replace some of the uncontrolled rock fill with engineering fill with a very good property, with high modulus of elasticity and high friction angle. So we tried to replace the first meter, then we tried to replace the second meter below the raft, and third meter and fourth meter. So we extend our trial to replace 4 meter below the raft. What we experienced through also stress analysis and 3D model, the settlement reduced to be 61 millimeter after replacing 1 meter below the raft, then reduced again to be 52 millimeter when we replaced 2 meter below the raft. And finally, when we replaced 4 meter below the raft, the sediment was 50 millimeter. For sure, this could confirm or give us an indication that the shallow foundation will not be visible in this case, because this is a very large settlement compared to the design requirement. As I mentioned, again, I remind you many times with this, our target was 30 millimeter only. So we start to think for sure about the deep foundation, and at one location at the same site there was a bi-directional loading test conducted for one of the bile at the site location. So we started to study the result of this loading test before taking the decision of deep foundation. As all of us know, the solution of deep foundation is very expensive, and this was not only one tank, it's many tanks distributed among the project. So taking this decision will be very costly decision. So beside also, we had to study if this deep foundation or the bile system will be visible if it was implemented within this uncontrolled rock fill. So the bile load test I will show in the coming slide was for a bile with diameter 800 millimeter with length 50 meter. It was a floating bile completely embedded in the rock fill layer. So this is a floating bile implemented completely in the rock fill layer. Also was erected inside the bile diagram. This is a traditional setup of the bi-directional static bile loading test, and the upper part will be boarded and the lower part will be loaded vertically. And for sure there were strain gauge distributed among the bile lanes to monitor the deformation and several levels. These are the results we obtained. The pile was loaded with 4,140 kilonewton. It was 300 times the design load of this pile, and the load distribution of the load transfer and load distribution along the pile was measured. You can see here it's unusual behavior of this pile. As you can see here, when the pile was loaded, the unloading behavior for example, in the lower part was almost a steady line. It was almost a straight line, which means that no rebound was obtained when the load has been removed. So when the load was applied, settlement for sure start to increase, and when the load has been relieved, no unloading deformation was obtained, or very, very minor values. So let's dig more and get a closer look about this unusual behavior. I'm not sure if you experienced something like this before or not. This was our expectation about the behavior of this point. As I explained, this uncontrolled rockfill has a large particles and surrounded with relatively small particles of fine soil. So when we start to apply the vertical load, due to the pore compaction, the soil around the pile may be compacted further under the pile load as the applied load, which leaves a less space for the soil to spring back, which is mean that the applied load continued the compaction process, which is initially was poor. This can happen in soil initially had voids or very loose compacted soil. The second expectation was the creep behavior. Usually, the slow deformation may not recover immediately when the load is removed. The third expectation was the gap formation. As you saw in the image of this uncontrolled rockfill, there is something like we called honeycomb-like zones. Under certain conditions, the loading can cause the pile to move away from the soil and creating a gap between the pile and the soil. When the load is removed, there might not be efficient lateral pressure to push back the pile effectively. That's why the unloading deformation was very minimal in that case. So with that in mind, it could be very, very risky to rely on pile foundation floating on uncontrolled pile. So in that case, we had to extend the pile length to reach the limestone layer, which will increase the cost more and more, which will be a very, very costly solution. So with this, we mainly commented on the visibility of shell foundation and deep foundation in such case. So as I mentioned, our scope is mainly give a lot of attention and caring a lot about value engineering. So what was a proposed solution for this unique case? We proposed stabilizing this uncontrolled rockfill using control modulus columns, which is CMC, or commonly known as rigid inclusion. I guess most of you may be familiar with this system. It's a column installed inside the soil that will be stabilized, and above this columns there will be a loading platform, a loading transfer platform, LTP, and the load and the foundation system, like any shallow foundation system, is placed above this loading transfer platform. The main mechanism or the main load transfer mechanism of this system is the arching action. When the load is applied above the LTP, the soil between those columns will settle more than the columns or the piles. So this will create arching action within the LTP and start distribute the transfer load through the LTP on the pile head more than the inside soil. It's commonly used in several applications like roadway embankment, storage tank, parking structure, isolated spread footing, and mat foundation and railway embankment. For sure, it's commonly used also with storage tank like the case we are experiencing today. The main difference between the behavior of pile foundation and CMC system is a load transfer mechanism. Mostly if you have the pile within a good soil, you will have the traditional bile load distribution, which is some of the load will be transferred through the friction, and some of the load will be transferred at through the bearing at the base of the bile. So this is a traditional positive skin friction at most of the time. In the CMC case, since we are dealing with settlement with expectation of high settlement or soft soil, the settlement of this soil could be more than the settlement of the column of the bile. So there are a great expectation for negative skin friction, like you can see here. Then there will be the neutral plane, then the soil will start to have some kind of positive skin friction again. So the load distribution could take this shape. Okay. Now let me show what we did to study the behavior of such system with our tank. This is a 3D finite element model we developed using MIDA GTS-MX, and it was also again a stress analysis to control or to study the settlement. And as you can see here, the soil layers, which is a rock, uncontrolled rock fill, was simulated, then the limestone layer, and above this layer there will be the LTB, which is a granular soil with very good properties, with high friction angle value and relatively good modulus of elasticity. And then under this LTB, there will be the columns or the CMC biles, which is distributed in a square pattern. We tried 600 millimeter diameter columns with lengths 12.5 to be rested on the limestone layer. If you remember, the depth of the uncontrolled rock fill layer was 13.5 meter, and if you deduct the LTB thickness, you will have about 12.5 meter length of the columns. So what we found that CMC with the LTB was able to control the settlement of this raft. So if you can see here, the settlement of the raft has significantly reduced to be 26 millimeter, which is less than the 30 millimeter, our benchmark, our target value based on the design requirement. Also, we checked the settlement of the column themselves. It was also within the accepted range. The vertical stresses of the raft was also within the range, which may confirm the visibility of this solution. But we have to dig more to start the designing process of this system. So we start to explore the differential settlement between the columns, the corner ones and the central ones, the variation in load transfer to each column. As you know, this CMC columns is plain concrete, so we have to check the structural design of this plain concrete columns and make sure that the applied load that will be transferred from the raft will be less than the structural capacity of such columns. In addition, for sure, the settlement, we have to control the settlement of this column to be within the accepted range. To do this, we start to extract the result from the MIDAS GTS model. And here is the pile load distribution or column load distribution. As you can see here, the first part, around 10.5 meter, experienced negative skin friction. Despite this high friction angle and high plate loading result we obtained from the plate loading test and SPT test for this uncontrolled rock fill, but you can experience here negative skin friction. The main reason for this negative skin friction is that the uncontrolled rock fill has settlement more than the bile, which lead to have negative skin friction at the upper part of the column. The neutral plane was located at 9.5 meter, and then the skin friction turned to be positive again. We use this load distribution to obtain the geotechnical capacity of this columns. I highly recommend to use federal highway standard to calculating the geotechnical and load transfer mechanism of this system. As I explained, the main concept of such system is arching action. So we had to ensure that the section or the thickness of the LTB utilized in our system will be efficient or sufficient to generate the arching action above the column's heads. So we check the critical heights using the Federal Highway Standard and Aziri recommendation as well. So the arching action, as I explained, transferring the load transferred from the LTB to the bile head to reduce the load transferred to the in-between soil. As you can see here, my desk model was very helpful in ensuring the arching action. As you can see here, the vector's direction may be confirming the load transfer direction. As you can experience here, the load has arching action and transferring most of the load to the columns. For sure, a portion of this load will be transferred from the soil, which is fine and which is lead to the negative skin friction, but we have to check that the soil is able to also resist this load. For the uncontrolled rock fill, we had no problem with the bearing capacity and the shear strength of the soil. As I explained, it already have very high frictional values. The main problem of the restructuring and uncontrolled settlement of the soil. It was not load transfer problem. So this the photo below here for another case, if we can utilize geosynthetic reinforcement within the LTB, which is also a common practice. It's used if you experiencing large shear stresses through this LTB. We can also use the geosynthetic to increase the efficiency of load distribution. When the load is applied through the LTB, the geosynthetic will start to bend, generating tension forces, and will contribute to distributing the load among the column head, like you explained here. This also is promote the arching action, which will be enhance the load transfer mechanism. So I guess these photos are very clear for the load transfer mechanism of such system. Again, we back to the value engineering. And the first distribution of the columns we proposed was, as I explained, has 12.5 columns length and was distributed in a square pattern. The total number under this tank was around 150 column. So we start to conduct some parametric analysis to foster or to experience the most optimum solution of this case. And we try to change the pattern of the CMC distribution among the raft under the LTB for sure. And we tried to change the length of the bile. As you can see here, this is just a few samples from the trial we conducted. We tried to change the length of the bile with different lengths. We tried 12 meter, 15 meter, 16 meter, 12 meter, and so on. So as you can see here, the neutral plane was changing with the changing of the depths. For sure, this is function in two main items. First, the settlement of the bile and the settlement of the soil, and the shear stresses at the interface between the pile and the soil, the neighbor soil. For sure, the neutral plane, the common definition to figure out the location of the neutral plane, it is the point at which the settlement of the soil will equal the settlement of the pile, which is mean after this, the skin friction will start to be in a positive direction. In addition, at this neutral plane, the shear stresses between at the interface between the soil and the pile will be zero, which is means that the skin friction will start to turn it to be in the positive direction. So to know the location of this neutral plane, you have to simulate the behavior and establish a numerical model like the one I presented. And to optimize your solution, you have to conduct hundreds of trials to achieve the best distribution of the pile, the best pattern of the distribution. You have many options like square pattern, staggered pattern, and triangular pattern. You can change the spacing, you can change the pile and length and diameter. So you have hundreds of options. For this, we try to utilize genetic algorithm using the data we collected from the parametric study we conducted through MyDatGTSNX. We start to extract the result of pile load settlement and pile load distribution for 5 trials I presented in the previous slide, and started to use this data to build a genetic algorithm model that could do a lot of trials and give us the most optimum solution. If you are not familiar with what is a genetic algorithm, it's a research heuristic inspired by the process of natural selection, like father and mother and parents. If you have a father and mother with certain genetic behavior or characteristics, for sure the child that will be generated could have some characteristics from the father and some characteristics from the mother, and you can detect this characteristics or themes very clearly. So to select the most appropriate or the most consistent child of those parents, you have to set something called fitness function. This fitness function controlling the selection process. For example, let's back to the CMC. I have the CMC and loaded with axial load, and I'm calculating the skin friction, the end bearing, the settlement of the pile, the settlement of the soil. Then I collect all in one or 2 charts and start experiencing the location of neutral plane. So if you have hundreds of trials, which one will be the accurate one? For sure, you need the function to be defined within the algorithm to explain to the algorithm how this will be accurate result or correct result. So you have to define an equation that describe the location of neutral plane. In our case, the location, as I explained here, was the location of neutral plane was the location at which the soil and pile settlement will be equal, and the differences of the shear stresses at the interface between the soil and the pile will tend to be zero. This was the criteria we utilize to develop or to establish the fitness function of our algorithm. We utilize TZ method to calculate the pile and soil settlement and conduct hundreds of trials to know the location of neutral plane in accurate manner. And this is a quick video. You can see here the software we developed, it's the algorithm I mean. Here we are uploading the Excel files we obtained through MyDatGTSNX. Then we started the optimization process. As you can see here, a lot of generation are developed, and generation here main trials, which is it's conduct a lot of trials, changing the length of bile and start experience or calculate where is the neutral plane will be. For sure, many of this generation could not meet the fitness function we defined, which is, as I explained, the bile and soil settlement shall be equal and shear stresses should be zero at the interface. So here, as you can see, there is a result of the generations. For each one, the algorithm is calculating the load settlement behavior and the load distribution of the column, the settlement of the bile, and the settlement of the soil, and start comparing them. It start to compare the bile settlement and soil settlement and find where is the location of the neutral plane among those the whole generation. As you can see here, this was the generation number 10, which meets the criteria. This algorithm conducted 100 generation, which is 100 trial. And as you can see here, the location of the neutral plane that obtained was around at level 10 meter. And at this line, as you can see here, the skin friction tend to be positive, and above this one it was negative, and at the same location the settlement of the soil become equal to the settlement of the bile, which meet the criteria we explained. With this was the optimum case, which is we utilized in our project. And finally, I have to acknowledge the EcoNstruct team and my colleagues working in this very interesting case study. The Geotechnical Engineering Department led by Engineer Ahmed Sharif and my colleague, the junior Geotechnical Engineer Mohammed Kamal. And I would like also to thank my undergrad students. They working with me in developing this genetic algorithm, which is was very wonderful experience for the student and for me personally. Thank you so much. It was my pleasure to be with you. I have to mention that my .NET GTS is one of the most preferable software I have utilized. I started to use it very early. I utilized it also in my PhD studies. I simulated many of the cases, including deep excavation, for sure, bile foundation, tunnels, seepage studies, and many cases. Thank you so much one more time, and I will be very happy to know your question and start answering. Thank you so much.
Итак, друзья, мы дослушали доклад доктора Ezzata, он с нами на связи. Hi, Dr. Ezzat, how are you?
Hello, how are you, Konstantin?
I'm fine, thank you. Can you hear me well?
Yes.
Okay, perfect. At first, I want to thank you for delivering such an insightful presentation. It was great. And now we have over 450 participants at this very moment. And we got a lot of questions, but due to time limit, I will ask you only a few of them, and I will translate it for you. You don't mind?
Yeah, sure. Please.
Okay, let's go. First, I will read the question in Russian, and after then, I will provide you with the translation. And after that, I will translate your answer into Russian for our attendees.
Very good.
Okay. So the first question in Russian. На слой известняка показан большой слой в 13 метров каменной наброски и еще 8 метров насыпного грунта. Насколько часто встречается такая геологическая ситуация или это особенность вашего региона? Не проще ли было бы проектировать резервуар сразу на слой известняков? And this question in English. A large layer of 13 meters of controlled rock fill and an additional 8 meters of planted soil is shown on the limestone layer. How common is such a geotechnical situation, or is this characteristic of your region? Would it not have been simpler or cheaper to design the tank on the limestone layer? Here is the first question.
Okay, actually, it's a very good question. Actually, this was not the natural geological formation. This rock fill was placed to raise the elevation at the site to maintain the targeted level for the tanks. Actually, it's a larger project with many of the tanks, and there is a complex irrigation and water system in the project that's required to elevate the tanks using this rock fill layers to maintain the elevations and the water systems. So we forced it to have touch rock fill above the limestone, and for sure it was not visible to place water tanks on the limestone. We hope we had this option, but we were lucky to have this complicated rock fill to study this case. Actually, it was very interesting. As I explained during the presentation, rock fill is not a common soil, especially if it was uncontrolled one. So it was very interesting to study the nature of such formation.
Okay, thank you. And now I'll translate it into Russian. Итак, коллеги, собственно, отвечая на вопрос, доктор Ezzat сказал следующим, что, конечно, было бы проще выполнить проектирование этого объекта на слое известняков, но ввиду того, что здесь показан только один из резервуаров, который входит в глобальную систему орошения и водоснабжения, это было невозможно, поэтому необходимо было соблюдать отметки, проектные отметки по всему объекту целиком, и для того, чтобы это реализовать, были выполнены работы по дополнению основания каменной наброской, и ввиду этого необходимо было учитывать также эти дополнительные слои по каменной наброске и по насыпным грунтам в том числе, для того, чтобы сохранять проектные отметки и выполнять дополнительные расчеты, чтобы, собственно, резервуар был устойчив и соответствовал проектным требованиям. Okay, the next one in Russian. Какие долгосрочные риски остаются при эксплуатации резервуара, построенного на неконтролируемой каменной наброске, и какие меры по мониторингу и контролю были предусмотрены для их снижения? In English, what long-term risks remain during the operation of tank built on uncontrolled rock fill, and what monitoring and control measures have been implemented to mitigate these risks?
Yes, actually, this is one of the most important questions. One of the main challenges with such uncontrolled rock fill is the creep deformation. This, due to the nature of this soil, it is very subjected to deform more and more with the time, and especially if it was experienced some kind of wet or shrink cycles. Because as I explained, it's restructuring again under the water cycles or different loading cycles. So we proposed in this project to have a zone loading test after the stabilization technique is implemented. And after this, we will have a zone loading test to measure the performance of the stabilized soil along long time interval to know more about the expected creep deformation that we might experience within the site. So such monitoring and measurement for the creep deformation will be very essential for live cases.
Okay, thank you for your answer. It was very detailed. Итак, коллеги, ответ доктора Ezzat был довольно объемным, но если привести его к одной мысли, то главным риском, главной проблемой в данных грунтах это была проблема, связанная с ползучестью скальной наброски из-за ее неоднородности и крупных включений. Соответственно, ввиду этого они дополнительно проводили определенные испытания и выполняли соответствующий мониторинг, и в случае отклонения от заданных значений дополнительно выполняли мероприятия по стабилизации грунтов от ползучести. Okay, the next one in Russian. В рамках параметрического анализа вы рассматривали изменение длины свай и ее влияние на результаты расчета, а рассматривалось ли влияние толщины? Okay, the question for you in English. In your parametric analysis, you considered the change in the length of the piles and its influence. Did you also consider the impact of the thickness of the piles?
Yes, actually, we performed several trials for other aspects like the thickness of LTB layer above the CMC and the diameter of the pile. But for sure, due to the time limitation in the presentation today, I was not able to present the result of all of these trials. Maybe in the next conference, we can provide more of these results. But for sure, this was included in our analysis and study. Yes.
Да, ответ доктора Ezzat заключается в том, что они проводили эти исследования, но из-за ограничений по времени не смогли включить их результаты в данную презентацию. И доктор Ezzat высказал желание выступить на наших следующих мероприятиях. Ну, будем ждать. Надеюсь, это произойдет. Okay, thank you. And last question for you for today in Russian. Как можно подробнее ознакомиться с разработкой genetic algorithms? Okay, in English. How can one learn more about the development of genetic algorithms in detail?
Actually, this is very important question. Genetic algorithms become more popular nowadays, especially in optimization problems. The engineer to start working with such technique should have first a background about the programming and the skills for using several programming languages. Then a very good understanding about what is a genetic algorithm theory and what is needed to build an efficient fitness function. As I explained, it's the main criteria that will be governing the selection process and the result that will be obtained at the end. So for this, there are for sure many references and books that could be utilized. One of them I can recommend a book named Genetic Algorithm in Research, Optimization and Machine Learning by Goldenberg. It's one of the good books that could be a start point in reading in this direction. And for sure, genetic algorithm is being used in many applications for optimization, not only for geotechnical engineering, for sure. So to find the references for this, you will find many. But first, you have to read about the methodology and the background that you should be applied within your problem. Yes, it's very useful. I highly recommend to start explore how can you use in optimization cases.
Okay, thank you. Ответ доктора Ezzat был довольно объемным. В рамках этого ответа он порекомендовал и дал ссылку на источник. Это книга. Здесь я предлагаю нам вернуться к этому позже. Мы напишем, что это за источник далее в комментариях, или вы можете вернуться к записи данного видеоролика. И помимо этого доктор Ezzat порекомендовал изучить основы программирования и также геотехники в части также машинного обучения и, собственно, объединить все эти знания и реализовать подобный алгоритм. У них это получилось, и, собственно, это, скажем так, отправная точка, с которой вы можете начать и в дальнейшем развивать данное направление. And maybe the last one for you for today. This is a small question personally from me. Did you use any kind of AI model? And if so, what model?
Okay, this is a good question, Konstantin. I guess you are sharing the same interest now. Actually, yes, I started to use several AI models, not in this project. In this project, genetic algorithm was ideal because it's mainly optimization case. But for another projects and another research initiatives, we started to utilize AI in different approaches. For example, one of the models I highly recommend, and you can start to dig more in this model, is called physics in term neural network model. This model has the option to integrate the theoretical equations with the machine learning techniques to give you a prediction, not only relying on the statistical analysis through the different machine learning models, but also integrating the theoretical part. For example, I use this model for predicting the axial capacity of large diameter bore pipes. You can rely on database of, for example, several bile loading tests you have in your database, and start training one of the normal machine learning like neural networks or something. But at that case, you will obtain a prediction mainly based on statistical analysis. This actually is very risky because it's highly dependent on the volume of the database you have. The more data you have, the more accurate prediction you will get. But unfortunately, most of us, especially in geotechnical engineering, we have a problem in shortcoming related to the volume of data. We don't have something like big data like other disciplines or so. So relying on satisfied volume of data may not lead you to a very accurate prediction through the traditional machine learning model. So I tried the physics in terms of machine learning models to include one of the theoretical equation. In the example I'm sharing here today, I tried to include, for example, Meinhof equation for predicting the axial capacity. So the AI model at that time was trained to predict through the theoretical equation of Meinhof plus the database I provided. It reached a very satisfactory prediction. I was happy on this result, but we're still working on such development of AI models that capable to give us reliable prediction. We can use it in a safe manner. It's a very good approach, and I will be more than happy if any of the attendees or my desk team would like to share the same interest and collaborate in this direction. I guess it's essential in the coming days. AI will be a fundamental part of our daily practices.
Okay, thank you very much. It's really very interesting. Okay, that's all for you regarding the question, and maybe you might want to say something to our participants.
Yes, I would like to thank you so much for being with you today. It was my pleasure to participate with Midas for sure at this wonderful conference. I went through the agenda, and I'm confident that many interesting cases have been presented within this conference. And I hope this was beneficial to all of the attendees. And thanks so much for inviting me to this. I will be more than happy to keep collaborating with Midas. Thank you so much.
Okay, thank you. Bye-bye. See you next time.
Bye-bye. See you. See you.